Hello students, today we are going to discuss about atomic structure. This is our part 2 video. Make sure you watch part 1 video which we discussed about basic knowledge of atomic structure. So, last day we discussed about energy levels. So, how many main shells are there in Niels Bohr's model? What is this? This is the nucleus. Around the nucleus, we have four energy levels, four atomic shells, four energy levels, right? So each level, each level have a specific number of electrons, maximum number of electrons that it can um, bear. So what are those numbers, right? So first shell is K. Maximum number of electrons are 2. So it's like, think this as a specific route. Only 2 vehicles can move there, transport there, likewise, right? So if we consider the next level, which is L, so there are 8 vehicles or 8 electrons. Then if we consider M level, maximum number 18 electrons can move. And also, if we consider the last outer layer, which we call as valence shell, last video I mentioned it. So, this is the valence shell, outer layer, outermost layer. So, this is N. So, 32 electrons can be there in maximum level. Right. Now, for the ordinal level, and specifically when we talk about chemistry, mainly we have to learn about 20 elements, first 20 elements, starting from hydrogen to ending from calcium, right? So those are the first 20 elements. There are more elements in the periodic table, 180, but at the basic level we are not going to learn about the other elements. Here we will focus on this in this model, in this set of videos. We will pay attention only for first 20 elements. Now we should know how to write electron configuration for all these first 20 elements. This is very important. Now, in order to write the electron configuration, what is electron configuration? It is the pattern of filling electrons. Pattern of filling electrons into these energy levels. So, from one to another element, it is different. Now, that is what we are going to learn today. Right? Pattern of filling electrons into these energy levels. Okay. So, for an example, first thing is you should know how to write first 20 elements with their symbols. It is a must. You should learn that. You should by heart that, and please study that. Okay. Now, because it is the basic backbone. If we tell like this, it is the important backbone of chemistry. Periodic table. Okay, so without knowing how to write symbols and elements, we can't go through the other parts, right? Okay, so if we consider hydrogen, it is in the first position. Why we call it as first position? Because the atomic number is 1. Okay, now there's a problem. What is atomic number? Now there's a problem. Okay, so I will do another video about atomic number and the mass number. It is very important, and also about isotopes. So make sure you watch the video which I have mentioned in the description box. So you will learn about atomic number, mass number, and isotopes. Right. So this is very unique for an element. So hydrogen atomic number is 1, which means if I roughly describe, inside the nucleus number of protons is 1. Okay, so number of protons and number of electrons are equal when the atom is in, we call as neutral state, which means there's no any charge. Now in further videos we will learn atoms will make ions. Atoms will make ions in order to be stable, right? So if they make an ion, we call them as ions, cations or anions, so we will learn, right? However, if we consider one particular atom, it is in neutral state. It is in neutral state, okay? It means there's no any charge. In that case, protons, number of protons in the nucleus and number of electrons in the energy levels are equal, right? So if we consider hydrogen, this is the nucleus. So what are there inside the nucleus? Protons and neutrons. Okay. So there's only one shell here. Now there's a problem. Why is that? How many electrons are there? Hydrogen is in the first place, right? So it means number of protons are 1. If so, how many electrons are there? As protons, number of protons are equal for number of electrons in the neutral state. How many electrons are there? Of course, there are only one electron. Okay, only one electron. So if there's only one electron, now we are going to fill it into the KLMN main shells, energy levels. So our first main shell is K, right? So how many electrons can be there? Maximum number? 2 maximum number is 2 in the K shell. However, here we have only one electron. So it's in their K shell. Okay, it's in the K shell. So this is how we are going to draw the atomic structure. So we don't have to write these. Now if I draw it again, so you can write E mark or else balls, right, to annotate electrons. That's not the case actually. If we use one ball as an electron, so this is the electron. So inside the nucleus, the blue color one is the nucleus. Inside the nucleus, protons are there, neutrons are there, and then electrons, number of electrons are 1, right? So how we are going to write the electron configuration? What is configuration? The pattern is only 1 because they are in the K shell. So the configuration is 1. Just 1. You have to write just 1. Okay. So we will go to another example. Right. So what is the second element in the periodic table in the first under the first 20 elements? Quickly. It's helium, right? So how many numbers of elements? 2, right? So it's there in the second position. It means number of protons is 2. It is equal for number of electrons. Therefore, the number of electrons in this neutral state is 2, right? What is the meaning of neutral state? It means no charge. Still they are not in the ionic states. They are in the neutral state. Okay, right. So if we draw this again, this is the nucleus. How many shells that there can be? Now first we will write the configuration, then you can draw this. Okay, right. Now there are 4 shells. Now only 2 electrons are there. So maximum number of 2 can be there inside the K shell. So no problem. Directly we can put both electrons into the K shell, right? So sorry, so inside the K shell there are 2 electrons. So what is the electron configuration? 2. Then how we are going to draw that? If I draw it electrons as balls in blue color, there are 2 electrons. 1, 2. Okay, so this is the nucleus. There are 2 electrons in the shell. Did you get it? Right. So we'll move to the next one. Lithium. Lithium. So lithium, what is the atomic number? 3, right? So it means it is in the third position. Number of protons are 3 and it is same for the number of electrons as well. So first we will write the configuration. Okay, K, L, M, N shells are there. Now how we are going to write the configuration here? So 3 electrons are there. Now first we have to fill it in the order. How many electrons can be there in the K? 2. Okay, no problem, it's 2. How many electrons are left? Now if we fill 2 in the K, how many electrons are left? 1 more electron. So we have to put it into L, right? So what is the what is the configuration? How we are going to write it? 2, comma 1. So you have to use a comma, okay? 2, comma 1. Right? So this is the configuration of lithium, right? So how we are going to draw that quickly? This is the first shell, which is K, and this is the second shell, which is L, right? Okay, so we will draw it nicely, right? It's the higher energy level than K, L1. So okay, right? So if I draw electrons in red color here, there are 2 electrons in the K, 1 electron in the L shell. Okay, so this is how we are going to draw. It should be a sphere. Okay, actually sphere in the sense it should be a kind of good circle when you are drawing, right? So that is how we are going to draw, right? Then next one, hydrogen, helium, lithium, then what? Beryllium. Beryllium is in the 4th position. Right, now 4th position, it means again number of protons is 4 inside the nucleus. Now you try to draw. First we will write the configuration. 2, how many are left? 2. So in the L shell we can bear maximum up to 8, no problem in that case. So we have to write it as 2 here, right? So configuration is 2, 2. Okay, so first one, second one, now you have to fill it. 2 electrons, again 2 electrons, right? So normally from the L shell onwards, we are filling those electrons as pairs. It is because now it's pairwise we are going to fill, because now K shell is no matter because only 2 electrons are there. But from L shell onwards, if you draw like this and this, now think if there are 8 electrons, okay? So if you draw like this, it's like something else. It's like a bulb set, right? So the examiner or the paper marking person, the person who's marking the paper, can't see it clearly. So there's a problem, right? So you have to make sure when you are drawing, draw those electrons as pairwise, right? From L shell to onwards, okay? L shell onwards, right? So this is the beryllium, right? Then we are going to move for the 5th position. What is that? Hydrogen, helium, lithium, beryllium, boron. Okay, boron, it's in the 5th position. So 2, 3 is the configuration. Make sure you write it correctly, right? Quickly write. Now you can draw it, okay? Now how you are going to draw? Here it's 2, no problem. The third one is in like one is in the pair and the other one is single. Okay, so this is how we are going to draw beryllium. Boron. Okay, right. Likewise, you can draw up to neon. It's the first 10. Make sure you draw it correctly. And if you have any doubt, question, please leave a comment. I will do another video with the answers. Right. So hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So up to neon you draw. And now I will draw neon. So neon is in the 10th position. So 2 electrons can be there in the K, and how many are left? 8 electrons. So we have to put it into L shape because 2, 8. Right? So you can draw it now. Draw pairwisely L shell onwards. Then what? Now there's a new thing I should teach you. If we move on to the sodium, this is also very easy. It's sodium 1. So there can be 11 electrons actually. It's in the 11th position. So 2, 8 in the if we take KLMN 2, 8. How many are left there? 1. So you have to put that 1 in the M shell. Okay, no problem. So you can draw it. M shell you have to draw and 1 electron is there. Make sure you draw all these things. Practice well. Okay. So sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. No problem. Now let's draw argon as well. So argon is in the 18th position. So 2, 8, right? So K, L, M, N, right? So how many electrons are left if it is in the 18th position? 2 is in the K, L, in the L shell there are 8. So how many are left? 8. Yes. So this other 8 electrons we have to put it into the M shape. Right? So no problem. You can draw this. So you can comment, and those who practice this well, you can put pictures and the scan document of your drawings and all. I will check it and give comments for you all through my Facebook page. I will mention it in my description box as well. Right. So the next thing. Now, this is the important thing. After argon, inside the first 20 elements, the other one is potassium. Potassium. So potassium is in the 19th position. Right? 19th position. So now tell me. K, L, M, N. So these are shells. Okay. This is the symbol of the element potassium. Why we are writing as K here? You know that. It's basic knowledge. But why we are writing it? Because you know potassium, the Latin name of the potassium is kalium. So you should write K. According to the Latin name, we are annotating the symbol. Okay. So now 19 can be filled. How many can be there in the K shell? 2. How many can be there in the L shell? 8. No problem. How many are left here now? 9 are left. 9 electrons are left. Now, this is the way we are going to write this. Maybe you have a problem. What is that? At the beginning I told inside the M shell, M main shell, they can bear up to how many? How many electrons? 18 electrons. M shell, the maximum number of electrons that it can bear is 18. Why we are not going to put 9 like this for here? But it's wrong. Why we are not going to do that? It's because now this chemistry is a vast area. There's a lot to learn, right? So we are learning only the basic knowledge. So if we take one shell, one level, there are subatomic shells as well, sub energy, like we call sub levels as well. It's like this. If you take a main road, there are branches. Likewise, short ways branches are there. Inside these M, N, L main shells, there are sub shells as well, sub shells, right? So those sub shells we are not going to learn in this level. It is in the inorganic chemistry, SPD. Likewise, there are sub shells. Okay, so because of that, now inside the M shell, even we can bear up to 18. We have to distribute those electrons among those subshells. But up to these first 20 elements, those subshells we are not taking into the count, right? So make sure you know this. Up to first 20 elements, up to which? Up to first 20 elements, inside the M shell, we only put electrons up to 8. So, in the K2L8M, only up to 8. Therefore, in the potassium, we have to put that one electron into the N shell. So, there's a story behind this. I just summarized it. There's a long story, right? So, it is not here applicable for this level. So, that's why, because of the energy differences, likewise there's a kind of huge story behind this, right? So this is how we are going to write for potassium. Make sure you know this. Up to this level we are going to put only 8 electrons for M shell, not 80. Did you get it? Right. So if you have any questions, doubts about this, make sure you leave a comment. Now you just try to write the configuration for the calcium, right? Calcium. And then leave the message, leave your answer inside the comment box below, right? So we will discuss these things. And make sure you draw atomic structures for all these elements. Now in the description box, I will leave the link of atomic number, mass number, and isotopes. Make sure you watch that as well. So we will meet in the next video, and we are going to learn about how the ion formation is going to be from the atom. Okay, thank you very much. Comment, subscribe, and give a thumbs up. Bye.